For this example, we're given the following triangle and have been asked to calculate the unknown length x. For any problem like this, the first thing we should do is label the sides. You should recall that the length opposite the right angle is the hypotenuse. The length opposite the angle that we're looking for, or the angle we know, is labelled the opposite, and the length next to that angle is the adjacent. Now we're going to have to use a trig ratio to find our unknown length x. And you should recall that your trig ratios are summarized by the expression sa, ka, toa. Recall that the sa tells us that sine theta is opposite over hypotenuse. The ka tells us that cos theta is adjacent over hypotenuse, and toa tells us that tan theta is opposite over adjacent. Now let's have a look at what we have. We have the opposite, which is equal to 12. We have the hypotenuse, which is our unknown x, and we have the angle, which is 25 degrees. So we're looking for the ratio that involves the opposite, the hypotenuse, and the angle, and that is sine. So we can see that sine theta is opposite over hypotenuse. So we can say sine of 25 is equal to 12 over x. I now need to rearrange to find x. So the first thing I should do is multiply both sides by x. So it cancels on the right hand side. So we see we have x times sine 25 is equal to 12. But we want to get x on its own, so I need to divide both sides by sine of 25. So I see that x is equal to 12 divided by sine of 25. Now I need to use my calculator to work this value out. So I want to put in a fraction. I put 12 in for my numerator, press down to get to my denominator, and then I want to write in sine of 25, so I press sine 25 and close bracket, and then press equals. So I see that x is equal to 28.39. X is equal to 28.39 to 2 decimal places. I have therefore used trigonometry to calculate the unknown length x, which I found to be 28.39.